Alright, in this video, I'm going to show you how to assign R and S. So how to give an R and S designation. What we're going to do here is we're going to use a really simple and systematic way to do that. A lot of the times they don't teach you this in organic chemistry, but you really do not have to use your mind's eye to solve these problems. You can actually use a systematic, foolproof way that always works 100% of the time. I guarantee you all, if you use this way, if you use this systematic method, you will never ever get a problem wrong in stereochemistry ever again. So let's go ahead and go step by step and see how to do this type of problem, or how to solve this type of problem, excuse me. So the first thing you have to do before you start anything, the first thing you always must do is check to see that your tetrahedral carbon has 4 different groups. So remember, in order for us to have a stereocenter, we need 4 different groups around a carbon, or any atom really, but it's most of the time it's usually carbon. So we have to check for 4 different groups. So do we have 4 different groups here? So let's check. So this is a hydrogen, so that's my first group. Nitrogen, NH2, second group. This sulfur right there, sulfur atom, third group, and this carboxylic acid right there, that's our 4th group. So yes, we do have 4 different groups, therefore we can assign R and S. Remember, if we don't have 4 different groups, we can't do an R and S designation. Alright, so our second point here is now we have to assign priorities. But before we do that, we need to figure out what are the priorities in decreasing order. So we need to assign priorities 1, 2, 3, and 4. And the way we're going to do that is using our systematic method here. So assign priorities. Alright. So what is our systematic method going to be? So how do you know which is first priority, second priority, third priority, and 4th priority? In this example, so as we all know, hydrogen is always 4th priority, right? So that's usually the one I always label first. I just, I find the hydrogen because, in most of these examples, it's usually always going to be hydrogen as your last priority. You always want the hydrogen in the back. And we'll get to that, what that means in a second. But in this example, our hydrogen here is of lowest atomic number. And as we all know, we go by increasing, or excuse me, our first priority is always our first priority is always the atom with the highest atomic number, and then we go in decreasing order until we get to the atom with the lowest atomic number, and that's our last priority. So in this case, there's nothing in this there's nothing in this molecule connected to our stereogenic center that is lower than hydrogen. So hydrogen is going to be the last priority. All right. So how do I assign the first priority? So let's go through that. I'm going to take you through that. So we go, like as I mentioned before, we're going to start with our highest atomic number. So we're going to look at this carbon here, and what is it attached to? So this carbon here is attached to this carboxylic acid right there. It's also attached to this amine group right here, this NH2. It's called an amine group right there. And then excuse me, one sec. And then it's attached to this sulfide group right there. So right here, this is a sulfide group. All right. So we have to look at the atom that it's directly attached to. So in this case, this carbon is attached to the sulfur, and I'm gonna write it out here first. So it's attached to the sulfur. And then that sulfur is attached to a carbon, which is also attached to two hydrogens, but I'm just going to write out one because we really only need three atoms right there. So we're going to write them out in decreasing order. So sulfur, carbon, and hydrogen. When it comes to the amine, I'm going to write out, obviously we only have three atoms that it's connected to, so I'm going to write out nitrogen, hydrogen, and hydrogen right there. And with this carboxylic acid group, I'm really only going to focus on this area right here because that's really all that matters. And so I'm going to write out, so first, initially, it hits a carbon. Before it hits an oxygen, this carbon hits another carbon, right? It's the carboxyl carbon. So I'm going to write it out here. So it hits that carbon. Now, what is connected? What is connected to that carboxyl carbon? And it's going to be an oxygen. But because we have a double bond, you're going to count it twice. And this is what you do with all problems. Anytime you see a double bond in these stereochemistry problems or a triple bond, so if you see a double bond, you would count that atom twice. So I'm going to write it out twice like this. If it was a triple bond, you would count it 3 times. Okay, so, but I'll get to that. I'll get to an example like that on the next video. But yes, so, and we have now written out the atoms that are directly connected to this stereogenic center. So now we just compare. Now we assign priorities based on atomic number. So which one of these atoms has the highest atomic number? And the answer, if you're thinking sulfur, you are correct. Remember, the atomic number for sulfur is 16. So we are going to start off with sulfur as our first priority. Our second priority, now we have to choose between nitrogen and carbon. If you don't have a periodic table handy, just remember that nitrogen is always nitrogen has a higher atomic number than carbon does. So that is going to be our second priority. And our third priority is going to be, last but not least, this carbon right here. All right. So now you see how we've done this. We've gone in order of atomic number. It's not by the biggest group. You know, a lot of people, when they're doing these problems, they see the carboxylic acid and they immediately want to jump to the carboxylic acid and give that the highest priority. And that is not always the case. You have to go by atomic number. You have to see what is directly connected to my stereogenic carbon. So what is connected to that, and you have to look at that first, and then you assign priorities. You can't just look at the biggest group first and say, oh, I'm going to give that first priority. It doesn't work that way. We're not going by atomic weight. We're not looking at functional groups. We're literally just looking at connection of atoms and their order that they're connected in. So don't go by functional groups and atomic weight and think that you can get away with assigning that as a first priority or a second priority, when again we're looking at atoms. All right, and so here we go. We have 1, 2, 3, 4. Now our third and final step, and you can do this in 3 simple steps. So our third and final step is to assign. So we're going to assign R and S. And I will show you all how to do that on the next slide. So again, I'm going to keep my priorities. We're obviously going to keep our priorities the way they were. And on the next slide, I'm going to show you how to do that. So here we go. So remember, this was our first priority. This was our second priority. This was our fourth priority. And this was our third priority. All right. Well, the thing about this problem now is that if we have a problem here. So our hydrogen is not in the back. So remember, in order to assign R and S, hydrogen must always be in the back. It must always be on the dash and not on the wedge. So how are we going to do that? And this is where the systematic method comes into play. And if you do this, you will never ever miss another one of these problems ever again. I 100% guarantee you. This works all of the time. It works 100% of the time. However, you have to do it correctly. And all I'm going to do is I'm going to do this. I'm going to switch my fourth priority and my second priority. So why am I switching those two priorities? The reason for that is because I want the fourth priority to be in the back. And that's because that's the only way you can assign RNS. If the fourth priority is pointing towards the back, then you can assign RNS. So I'm going to go ahead and switch the fourth priority to wherever the dash is. The dash just happens to be on the second priority, right? So that's why I'm switching 4 and 2. So that's what I'm going to do here. I'm going to cross this out, and I'm going to say this is my second priority now. I'm going to cross this out, and I'm going to say this is my fourth priority now. So I've essentially just switched 2 and 4. And now we have our fourth priority on the dash, and now we can assign RNS because of that. So now let's go ahead. I'm gonna write out. Let's see. I'm gonna choose a different color here. I'm gonna choose blue, and now I'm going to assign RNS. And so again, we're gonna follow. As you all know, we have to go. So what would that be? What would this be right here? Which direction is the clock going? This is counterclockwise, right? So that's counterclockwise. However, because we switched the fourth and the second priority, so as written here, it would be. So I'm going to write it up here, up to the bottom right. So as we have it here, it would be S. However, because we switched the priorities, we don't go off of the initial. We don't go off of the initial assignment of RNS. We have to switch them. Remember, we switched the priorities. So now, even though we have S here, all we're going to do is we're going to say that, okay, it's actually really R. It's really, really R, because we switched priorities 2 and 4. And so that's how you solve these problems. And again, if you do this if you do this and you do it correctly, you will get these problems correct 100% of the time. It's a foolproof method. It works all the time. If you don't have the ability to rotate these atoms in your head, then this is a systematic way that will get you the correct answer, again, 100% of the time. I really, really guarantee it. So in the next video, I'm going to go through a more difficult problem, and I hope that it starts to make a little bit more sense. Thank you very much for watching, and stay tuned for the next video.